Notice how its position is just... I just remembered why. I know exactly why it's not working. You won't be able to guess why, because it's weird. Not yet, Forge. This is only my first one. Maybe I'll get there. Yes, I do know what Balmer's Peak is. What's the state diagram? I'm going to draw you the state diagram. This is the state diagram. Let's resize. I don't know, like 1800 by 1000. Here we have a big canvas drawn. No, that's too big. 900 pixels. There we go. Okay, here's my canvas. I'm just going to draw you a picture. Okay, we're going to draw it in red. So, by state diagram, I assume you're talking about like the general way of how this game is put together. Is that what you're talking about? So basically at the top we have, right, our game. G-A... God, I'm terrible at this. M-E. Here's my game, right? The game is basically this loop where when you run the game and I hit run, and that's where it starts. And the first thing it does is it does an initialize step. And that's what a lot of this code is. It's initializing things, it's creating classes, it's setting up dependencies, it's doing a lot of the codey technical stuff that it needs to make the game run. After it inits, it then moves on to a loop, actually. So I'm going to kind of do this. And what it's going to do is it's going to update. And this is kind of a simplified version, but this is how it works. It's going to update. And that means update everything in the world. Update being... Panzer, that's really nice of you to say. Oh, thanks, Charmer. Yeah, I've been practicing for... I've been practicing... Also, hi, Charmer. I've been practicing writing in Paint. By update, that means... conceptually update everything in the world. So when you have objects, move them. If an enemy has AI, like, you know, figure out where the player is and update the AI. If there's a bullet, make it move through the air. If there are particles, move them. If there's a timer, advance it. Do all the updatey things. And then what it's going to do is it's going to flip around here. And it's going to go to the draw step. Draw. Maybe I should highlight it. Thanks, Dappy. And then it's going to do this. And pretty much it's an infinite loop. Which makes sense if you're running your game, right? It just update draws, update draw, update draw, update draw, update draw, and it just goes back and forth. You update everything, and then you... Remember the illusion of movies, right? Nothing's actually moving, it's just drawing still frames. It just does them fast enough that things appear to move. In this case, hopefully it's running at something like maybe 30, you know, or like 60 frames per second, right? When your screen is being fully refreshed... Oh yeah, in this case, update is physics, among other things, but update is physics. That's a weird looking penis. Was not expecting that. Hi 2am. What's up? You're generally interested in how data is flowing from the world to individual objects, etc. Sure. So this is the way that... This is nothing specific to my game. This is pretty much how, in a nutshell, every single game works. And so 30 to 60 times a second, depending on what your frame rate is, and assuming it's consistent and everything, you update everything in the world and you clear your screen and redraw it. And if you do that 60 frames per second, it appears as if your game is moving, right? 2am, that is quite funny. Oh my god. This is a weird looking deck. Here, wait, let's do this. Okay, here is our... There we go. Now it's a penis. There's the penis. Okay. So, would moving between areas trigger a new initialize step in the game, such as Ori? Sort of. Again, this is the simplified view. Imagine you're playing Pong. This is what the game looks like. And it applies to games like Ori or like Call of Duty or any AAA game you could find. That said, there are some in-between steps. So, start with Pong, right? Pong, you have nothing... You load the game and you have the whole game. You don't need to load a new area. Notice how Ori has no load zones. Same as GTA 5 or whatever. A lot of games don't have any loading zones. These games are too big. Make it move now? Oh god. That'd be difficult. Remember that these games are too big to fit into memory. Like if you took all the memory in terms of actual bits and stuff, you would need to store every texture in Ori and every enemy and everything. It would be too much. Your computer couldn't store it. So because of that, where as it appears you're moving through the entire world without having to pause for any loading. The game is actually loading under the covers, it's just you don't notice it, and it does it in such a way that it doesn't mess up the frame rate. So from your perspective, it appears as if the entire world is loaded all the time, even though it isn't. So basically what it would be is, and this is kind of what you said, this is what you just said, Pats, let me make it blue, as part of the as part of the update step, sometimes you might say, like, if you hit trigger, so let's say if you hit a certain trigger, like a loading trigger, then you load a new area. And then after you've loaded it, the same thing is updated and drawn, because kind of on the side of this you have all of your entities in the game. So you have your entities, and you have your particles, and you have your what else, like your music, you have like controls, you have all the things that are kind of being used every frame, right? How do events propagate from an individual object to the world? Is that something in a loop or separate pub thing? That doesn't happen in a loop. That happens, again, the whole game is looped, but think of individual steps. Shaders would be in the draw step. Think of each of these steps as a series of instructions. So think of it this way. There would be many more than 4, but imagine you're looking at, what the hell color do I have? Purple. So imagine you're updating, and imagine you have 4 things. You want to update your enemy, update your player, update particles, update your loot, update the music, and then update an NPC, right? Imagine your update step is actually a lot of different steps. Some of those steps include sending events to the world to update the state of the game. Let me say this. This part over here, this part over here is the state of the game, where you could take a snapshot of it. Like if your game froze in the middle of the game, you could look at everything exactly as it is. Is an enemy attacking, or is it running away? How much health does a player have? All the different things that you would define as the state of the game. And that can get pretty complicated, but that's the state of the game. What the update step does is it updates the state of the game. Period. That's what your update step does, is it updates the state of the game, which might include adding additional entities by loading them, or adding particles if you make a shot, if you fire a fireball and then it explodes and makes particles, or maybe you enter a new area and new music starts playing, but you're still just updating the state of the game. The draw step does nothing to the state. It does not update the state. That looks terrible, I need to redo that. The draw step does not update the game, at least conceptually. All it does is look at the current state of the game and draw it. You could almost think of it as something like this. So again, you start your game, you initialize, and then you start updating the drawing on the state. Is it all synchronous? I guess what I'm asking, is updating state sequential? In a simplistic case, yes. For a AAA game, no. For a AAA game, you're going to have multiple threads that are updating different things asynchronously. Like, so here's the thing. You want your game to run at, say, a solid 60 frames per second, right? Say that's your goal. You want it to run at a solid 60 frames per second. What that means is that this process, this update and draw, both of those things have to complete within a 60th of a second, right? Because if they don't, it's going to infringe on the next frame, which also has to update and draw in another 60th of a second, as does the one after that. So if everything in your game can update and draw within a 60th of a second or a 30th of a second or whatever your frame rate is, then you can do it, Denger, like you said, you can do it all synchronously, you can do it on one thread, and no, you're not derailing. I like talking about this stuff. I'll get back to programming in a minute, but if your game is simple and small enough, or your computer's just powerful enough that you could do all of this in a 60th of a second, then you can do it synchronously. However, imagine that your game was a huge AAA game and it's complicated enough that if you tried to do everything in order, it would take more than a 60th of a second. If that was the case, you couldn't run your game at 60 frames a second, right? because your draw step can't draw if everything isn't done updating yet. So you would maybe have like one thread for all your entities and one thread for your particles. Panzer, that is so nice of you to say. Thank you very, very much. It's very, very nice of you to say. So imagine all of your entities, entities being enemies and players and whatever. There's so many of them. You have 1 million entities that you have to dedicate an entire core of your computer to doing those. And you have so many particles, it requires an entire core. And your music, for some reason, is so complicated that it takes an entire core of your computer to do it. What you would then do is this update step would actually kind of be 3 update steps at the same time. And these are happening at the same time, which means that they're happening asynchronously. The trick being that they all then have to kind of meet up at the same spot and say, I am done. Even though this one might finish first, then this one finishes, then this one finishes. So the trick with the benefit you get from doing things asynchronously is that you can update more. You can do more. Downside being you have to dedicate more of your computer to it, and you have to sync things up before you draw them. If you don't, you get things like screen tearing and things where things aren't quite in sync with each other, and you've seen that. That's something that VSync tries to reduce. Exactly, Denger. So this is, I guess, my state diagram. What the hell? Controls get their own thing as well. That's the wrong color. This is the right color. In a nutshell, this is how games work. And of course, within, similarly to the update step, within the draw step, you draw your first thing, and then your second thing, and then your third thing, and then your fourth thing, and then your fifth thing. And just like the update step, in a simple case, everything happens in order, and then in a simple draw case, everything happens in order. In a complicated game where there's more than you can do in a 60th of a second, you have to update multiple things at the same time. You also have to draw, like, sometimes multiple things at the same time. That's what shaders and stuff can do. Yeah, shit gets very complicated. Do you ever write an assembler to optimize certain aspects of your games? Absolutely not. That would be way too scary. Fun story, though. Did you know that Chris Sawyer wrote Roller Coaster Tycoon by himself? Like, he did all the programming by himself in assembly over 2 years? Like, how ridiculous is that? Just insane. So, no, Panzer, I have never had to do that. I think that maybe if you're making the highest quality, best looking games in existence, maybe you would have to do that. But I certainly have never made anything that would be... I've never made anything that would make my computer struggle enough where I would ever have to think about doing that. It's unlikely I ever will. Exactly, Red. Roller Coaster Tycoon is May. So here's my... I'm actually going to save this image. This is... Let's put it in documents. Game... Let's see. State diagram.png. Hey, Epic Cat. Welcome. So this is how the game works. Let's get back to this. So, and by the way, now that you understand this game and its update draw, look at this. This is my game 1 class. That's a game. Look at this. There's a method called initialize. That's init. There's a method called update, and there's a method called draw. So this initialize step is only going to happen once. The Fox, yes it did. Roller Coaster Tycoon did get programmed in assembly, and that's unbelievable. Exactly, Denger, what you said. C# does a lot of optimization for you. So here's my initialize step. This is only going to be run one time before my game starts, and then it's going to alternate between update and draw. So you can notice these things happen over and over. Each of these update and draw things describes one frame. So in one frame, what do you want to do? You want to update the world, you want to update any timers, you want to handle whatever input was done that frame, then you want to update all your entities in the world, and then you want to update your camera, right? And then when you draw, you just want to draw every entity in the world, because a lot of things are invisible, like you don't, like you could, but like you don't draw the camera. You don't draw your input, you know, it just, your input affects the game, but you don't draw. You don't draw timers. They're just done under the covers. Again, you can imagine you have to escape the exploding factory like Metroid style in like a minute, and you could have a countdown, but that's different. Generally speaking, you have an update step and a draw step, and you can see how that maps right onto here. So now, where was I?